unicorns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stack in stacks. For we pity let this city on sports and chains. We pity let this city with regen brains. We pity let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield, where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pity let the city on sports and chains. We pity let the city with regen brains. We pity let the city on sports and chains. No rug pulls, just pure on chain. If you faded, just stay seated. The Etherverse will leave you heated. We don't need your legacy, 'cause regen memes are brew upgrade. Bid let the city on sports and chains. We bid let the city with regen brains. We bid let the city on sports and chains. Rolling up and slapping chains.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernight whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Stay-doo-doo-doo, boo-boo-doo-doo-doo. Architect with the bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do-do, with a do-do, with a do-a-do, a do, with do-do-do, do-do-do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. spaceships. Scurry, hack, flurry. Mama's making moves before the code reloads. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive chump. Blood eyes everywhere, that's 3 bird phones. Chowdhury's whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk scene. Head it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with his firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it
Guitar slide. Guitar slide.
coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7 for time. Shaboom goes the efficiency pulse. The lad runs lagging in his latency sub. Professor Wade's got the future on spin ball. Urgent notes dancing where the bottlenecks been. Professor Wade's got the future on spin ball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin ball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin ball. Plugging tomorrow with yesterday's RAM stains. Chaos is not a compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs dial up found. Old as speak, young as each block mine down. Professor Wade's got the future on spin ball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin ball. Plugging tomorrow with yesterday's RAM stains. Calling me mad, but mad's just a beta test for Buddha. Just dreamers, on-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks.
floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Work marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we bet you at the city on sports and chains. We bet you at the city with regen brains. We bet you at the city on sports and chains. No rug pulls, just pure on chain. Chains.
She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking ether night whiz. Found her at a bullet hawk sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion.
Hello, I am Grigore Roșu. I'm the founder and CEO of Pi Squared. And our mission at Pi Squared is to bring all programming languages and the next million of developers to Web3. It is well accepted and broadly acknowledged and proved over and over again in surveys that fragmentation is one of the main critical pain points in Web3. Fragmentation of ecosystems, blockchains, providing different languages, different applications, fighting with each other for the users, to steal users from each other. Liquidity, billions of dollars spread all over, and the user experience is terrible. Everybody wants to fix it. Let me tell you how we want to approach, how to solve this problem of fragmentation. Through universality. Universality at 3 different levels. First, universality in programming languages and program execution. We firmly believe that all programming languages should be available to Web3 developers. Universality with respect to verifiability and proof mechanism. Verifiability should not be negotiable. Every execution should be provably verifiable. And we should also allow different proof mechanisms. We should not be stuck with just some of them. Also, universality with respect to distributed consensus protocols that assure security. We should be able to achieve consensus at the speed of light for applications that operate that way. How precisely we do that? So we offer a universality stack containing 3 components: the universal language machine, the universal settlement layer, and the universal consensus protocol. The universal language machine is a blockchain architecture that allows you to write smart contracts in any programming language, existing programming languages or new programming languages, even in programming languages that have not been invented yet. You can even bring your own language, BYOL. Plug and play your language into the blockchain and then write smart contracts in the language. ULM builds on top of the USL, the Universal Settlement Layer, which allows you to generate proofs of execution for any programming languages, executions with any programs in any programming languages, therefore proofs also across different ecosystems based on different languages. And also it is fast and low latency settlement. And when we talk about proofs in this presentation, we mean two types of proofs, both mathematical proofs and zero-knowledge proofs. Usually, in the blockchain space, we understand zero-knowledge proofs by proofs, but you'll see that mathematical proofs are even more important when it gets to actual correctness. And the USL, to achieve all these performance benefits, builds on top of the Universal Consensus Protocol, which is a consensus protocol for claims that are true, and it is not based on or relies on a total order of transactions. It is a set consensus protocol. You achieve consensus on a set of truths. And this can be done, amazingly, at the speed of light. Literally, all you need is a round-trip message between the client and the verifier to get confirmation that this claim is true and to achieve agreement on that. All right, so what does this really mean? Well, it means the following, that through ULM, we can now bring all the developers in the world to Web3. They can use their favorite programming languages. They no longer have to learn obscure programming languages in order to be part of the Web3 space. That includes millions of developers out there, tens of millions of developers, not to count all the AI agents who are also programmers themselves. USL, what it really means is that we can settle correct executions on this common layer across Web3, Web2, all kinds of applications. Any computation that has nothing to hide, that wants to prove that it happened correctly, can settle on the USL. Web2 or Web3. Everything, everybody, any computation can settle. AI agents can settle their inferences. And UCP means that we no longer have to wait seconds for finality. It will happen at the speed of light. I don't need to tell you how important that is and what opportunities this brings. Basically, any developer in any language can now participate in the Web3 space. We no longer have to go with only 20, 30,000 programmers like today. We can very quickly extend to 20, 30 million developers, not to mention all the AI prompt engineers. Programs in the future will be written by AI agents, not by humans. And all those will participate as well in the Web3. All right, so enough talk about universality in general. Let's now go deeper and try to understand why we need universality. Actually, instead of why, actually that's not the right question, why universality. The right question is, why don't we have it yet? Because you want universality. I hope I convinced you that we want all that universality to eliminate fragmentation or reduce fragmentation. Why we don't have it? Well, programming languages come into the picture here. This slide shows the state of the art in the programming language field. It's a lot of pain, what this slide shows. Basically, every single programming language combined with any single tool is an arrow in this picture, and that means a whole complex system by itself. For example, C and compilers. We have GCC, ICC, Clang, tens of years of effort, hundreds of many years of effort. Or Java interpreters, or EVM interpreters like Get, Rest. So all of these tools need to be developed and need to be maintained. You cannot just add a language to an ecosystem. You need to bring all the tools so developers can develop actual programs properly using the language. So maintenance is a hell, training developers is hard, and tools are always behind 2 or 3 versions of the actual language. So bringing a new language to a blockchain, or anything for that matter, is a big deal. And this is what we believe is a major barrier, a major obstacle that we have to avoid. Well, how can we do that? How can we avoid that? And this is what we believe is the key to avoid all this fragmentation of programming languages and eliminate the barriers brought by programming languages. This is not a new idea. I proposed the K framework back in 2003 when I started my career as a professor at the University of Illinois. And I built it with my research lab, my students. Then several companies adopted it, several other universities adopted it to teach programming languages. But this is the idea. Okay, actually, let me tell you what I don't think is the right way to go. Picking one particular language, no matter how beautiful the language is, and no matter whether that language is high level or low level, LLVM, any language that you think this is the best language ever. And by the way, I mentioned LLVM because it was invented in our department at the University of Illinois, so I can mention it. So pick LLVM, no matter how beautiful the language is, it will never be the ultimate programming language, right? So if you compile translate any other programming language to that one language, you will suffer from the same problems like before. You'll have compilers that you have to keep updating, you'll have each tool that needs to be updated, and you'll have errors, and so on and so forth. So we believe that the solution is to actually do the exact opposite, which is what I proposed back in 2003. So instead of translating everything to one language and call it the ultimate language, instead of that, what we do, we define everything mathematically. Every single programming language is a mathematical theory called a formal semantics. Let me ask you a question here. How many of you here knew, and be honest, that in order to talk about correctness, somebody gives you a program and says this program is correct. So in order to even talk about correctness, you need a formal semantics of the programming language. How many people here knew that? Nobody? Okay, you see? So that's what happens. People talk about correctness all the time, but in order to have correctness, you need a formal semantic, which is a mathematical definition of the programming language. Once you have that, a universal language framework, like the K framework, will generate for you all the tools that you need from that mathematical definition, including an interpreter. Okay? So you don't have to implement an interpreter by hand, you don't have to implement a compiler by hand, you don't have to implement a program verifier by hand anymore. All right? All of them are generated from the actual mathematical definition of the language, and they are correct by construction. What that means is that everything they do, including the interpreter, which executes a program, everything they do is done using a mathematical proof under the hood. Okay, so you can take that mathematical proof and check it, and now you know with absolute certainty. Forget zero knowledge proofs. There's not absolute certainty. But this is absolute certainty that the execution happened correctly, because a mathematical proof was constructed, and that mathematical proof was checked. All right? So that's the magic of a universal language framework. Any programming language in the framework is a mathematical ground truth, a set of axioms, and now everything that you do in terms of execution, verification, everything you do with that programming language becomes a rigorous mathematical proof that can be checked. So this is the key that allows us to get universality, because there is nothing specific to any particular programming language here. And you may say that, yeah, that's great, but it must be horrible to define a language mathematically. And I can tell you that no, far from it. It is actually easier, and you don't have to trust my word, just look at this slide. It is easier to define a formal semantics of a programming language than to implement an interpreter for that programming language in some ad hoc programming language. What you see here is a complete language definition of a simple programming language, but what is important is that it's complete. On the left, you have the syntax. You can see the if then else statement, for example, here in the middle. To the right, you have the semantics. All right, the if then else, notice that it's strict in the first argument. You have to write strict in the first argument. That means that it evaluates the first argument. And then in the right side, where you have the semantics, the actual axioms defining the language, we have two different rules, one when the first argument is 0, one when it is not 0. Exactly what you would expect. I claim that this is much, much easier to read than an actual interpreter for the language. But the beauty of this is that this is very rigorous, mathematically very rigorous. And yesterday, on the same stage here, we demonstrated how ULM works and how smart contracts written in this language actually execute. All right, so now what is pi squared? Pi squared comes from proof of proof, specifically from zero-knowledge proof of mathematical proof. Okay, remember that in K, when you execute any program in any programming language, you get a mathematical proof under the hood, right? Wonderful. The problem is that that mathematical proof can be big, and it is big, so big that you may not even be able to store it. So the secret is to actually discard it as it is generated, you check it, and you generate a zero-knowledge proof of its existence. And this is where the name pi squared comes from. Zero-knowledge proof of mathematical proof. All right, this slide shows the big picture, which we call verifiable computing 2.0. Why? Because this is verifiable computing as we know it, but universal. It works with all programming languages. It is correct by construction. No ZKVM to be formally verified. All right, this is how it works. Let's start with the output. At the output, we get a zero-knowledge proof, same like in any other ZK circuit. At the beginning, you get as input a program and an execution environment. Don't look at this yet, which is exactly what you get in any ZKVM, which is specialized to this particular programming language in which the program is written. What is different here is that the programming language itself is an input. All right, and then K does its magic and generates a mathematical proof from the execution of the program. Right, so now I don't have to trust any of these complicated stuff because I verify the mathematical proof. Once I verify the mathematical proof, I know that the execution was correct with absolute certainty. How can we do that? Well, we can do it using ZK technology. So now we completely separated concerns, computation from cryptography. Computation is verified with the best that we know after more than 50 years of research in programming language semantics and formal semantics in general. Now we are done with this part, and now we can focus on just one aspect. Let's generate a ZK proof for mathematical proofs. This builds on everything we've learned in probably in the oldest field of computer science, programming languages. And it is not only universal, that it works with all programming languages, but it is correct by construction. There is nothing to formally verify here. And formal verification is my field. That's what I've done all my career. Now, finally, we don't need it. All right, and this is my last slide. Let me tell you what the current status is. We are a new company. We started 1 year ago, exactly 1 year ago, at ETHDenver 24. And this is what we really wanted to do back then. First of all, no matter how many times I said correctness is critical, in the end, everything boiled down to performance. Everybody asked me, yeah, but this is going to be slow. Great, it will be correct, everything correct by construction, but it will going to be slow. Not anymore. So we had to improve the performance of K by 10x, to make it 10x faster, in order to be convincing. And now it is actually 15 times faster than it used to be after 1 year of effort. Now it's 1.58 faster than GET. Okay? Please, if there is one thing to go home with, this is the most important thing. You execute a program generating a mathematical proof using a prover, and you get a proof of correctness for the execution of the program using the most rigorous known framework for correctness that we humans know. And that happens faster than an ad hoc manually written interpreter, which is the most used client in blockchain. Okay, so this is fascinating, for me at least. It's the first time that happened. So formal semantics, whoever tells you that formal semantics is great but it's slow, tell them not anymore and send them to this. By the way, all these papers confirm and explain how it happens. So this paper explains all the engineering that has been put into this, how to make it really, really fast. The second thing we wanted to demonstrate was that proof of proof makes sense as a concept, that we can indeed generate zero-knowledge proofs of mathematical proofs. And we plan to do it with just one zkVM with risk zero. But what happened was that once we started getting results, we were approached by other friends, different other ZK with other zkVMs, and before we knew it, we ended up putting together a benchmark, which now is the largest benchmark for zkVMs that we are aware of. Has almost 10,000 programs, more than 1,200 programs, but multiplied by 7, because now we run them with 7 different zkVMs. And yeah, so it's all open source. If you have a zkVM, please try it and add the 8 or the 9th or more. So the bottom line is that now, because of what I showed you previously on the previous slide, we can bring all programming languages to all zkVMs. Okay? You no longer have a zkVM for RISC-V or for EVM. No, now you have a zkVM for all programming languages, without any compiler to your language. And finally, we wanted to show that we can indeed settle on the USL claims corresponding to blocks on Ethereum, and we've done a lot more, actually. We managed to integrate with Wormhole. So USL now provides an alternative to the Guardians on Wormhole, which we all know they are a big pain. They run full nodes on all the networks. So now you can settle everything they do on the USL, actually. And one other thing that happened last year is that ULM, the blockchain architecture that supports all programming languages, plug-and-play your language, now is actually alive. It's not a blockchain, it's still in our lab, but it's a proof of concept showing that, yes, you can plug and play your programming languages, and then write smart contracts in them, and then you have interoperable programming languages. So interoperable programming languages, interchain applications, everything going through mathematics and mathematical axioms, and 12 mathematical proof rules that can prove anything about any theorem about any mathematical theory. So, all right, with that. And by the way, all this demonstrating USL and ULM, have been recorded. They are on YouTube, on our webpage. Please try them out. Watch them first and then try them out. And with this, I'd like to invite you at our booth as well, 402, right next to the coffee place, and see a live demo of USL and ULM. Thank you.
Architect with the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it.
To supply.
Click, clack, goes a mace on firewall. I scooped and truce from trash sheets. That's my device. Nullifier sniffing by my copes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, that's 3 bird phone. like, who's got the keys? Nullifier's huffing, you're just a rat with hair. As firewalls splinter to confetti bits, I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lad runs lagging in his latency so. Notes dancing where the bottleneck's been. Professor Wade's got the future on spin. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the boot fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin. Urging notes dancing where the bottleneck's been. Professor Wade's got the future on spin. Bugging tomorrow with yesterday's ram stains.
Hi everyone, if you can hear me and you're somewhere in the Build Hub arena, I invite you to join us now on the Captain Ethereum stage. Please join us for a set of very interesting presentations. What? Very interesting presentations about Ethereum scalability, programming languages, and how to build, various ways to build apps. So joining us now we have Hilmar Orth, who is the co-founder or the founder of Gelato, coming to us from Switzerland. So we'll start in a minute as soon as the live stream is ready.
Awesome. Hey, thank you everyone who came to today's presentation. My name is Hilmar. I'm from Gelato. And today I want to talk to you about the ABC stack, which is a new rollup stack that we've been developing at Gelato. And it's the first stack that broke the 1 gigagas per second barrier. And it's a new form of rollup stack that we are very excited about, which is called sovereign rollups. And today I want to talk to you about the motivation behind building it. What is kind of like the reality of rollups today in Ethereum? Then actually, from our experience with working over 50 different rollup customers, what do they actually want? And then, how ABC was designed to actually address some of these problems that we identified. So why am I on the stage talking about this today? Well, we, in the past like 1.5 years, we worked with a bunch of different teams together and helped them deploy their rollups. A lot of notable teams that you might have heard about using all sorts of different stacks. I think we used the ZK stacks, the optimistic rollup stacks, all of the different sort of frameworks that you might be aware of. And we look always, of course, how our customers are using those, what are the use cases, and do they actually use certain services as if they're like they're designed to be used or not. Then of course I will talk a bit about like ABC Stack and why for a certain user group we believe it's actually a very interesting and compelling use case. So just as a reminder for all of us, I think there's a lot of confusion oftentimes to like how rollups really work. So a rollup, at the very essence of it, is a blockchain that posts its data, it posts its transactions to another blockchain in order to outsource security and consensus around an ordered list of transactions. That's basically it. That's like a common definition of what a rollup is. Now, where a lot of the confusion usually arises is that in most of today's sort of rollup frameworks, we always have a bridge enshrined to the actual rollup itself. So we talk about the rollup as, when we say rollup, we usually mean the rollup and the bridge. And why this is the case is because these rollups were designed with like Ethereum as kind of like a hub in mind. So when they were first sort of initiated a couple of years ago, there was like, okay, we have Ethereum. Ethereum is the base layer for everything. On Ethereum, we will create all the assets. We will issue all the assets. And then we will have these sort of network extensions to Ethereum where people can bridge assets into, out to again. And we can secure this bridging via proofs, fraud proofs, ZK proofs. You can do TE proofs, whatever you like, right? And this is really what like people think about Ethereum L2s today. What a rollup is. They usually say it's the rollup plus the bridge. And what we did is we had the L1, then we had L2s on this L1, and now there are L3s on top of L2s, and now there might be L4s on top of L3s, right? So this is kind of like this sort of hub and spoke architecture that arose. And why do we sort of like do this, right? Why do we design it? Well, because as I mentioned, these rollups were not really thought of as like individual chains that should do their own thing. They were like more like network extensions to Ethereum. So they should actually feel like Ethereum, but not being part of the sort of layer one. Back then also we had a bunch of like very complicated bridge hacks, and bridges were like custom built for every single L1, and there were a lot of issues with that. So enshrining this bridge into the system kind of like made sense. And back then, literally 99% of all the assets were issued on Ethereum, also the stable coins, right? And so, yeah, thinking that Ethereum is the hub for all the assets also made a ton of sense. But yeah, let's look at some data here, right? This data is directly pulled from like L2Beat. And yeah, what do these sort of like layer 2s that you see right here have in common? ZK Sync Base, Real, which is a real world asset chain, Arbitrum, and so forth. Well, all of them actually have the majority of the assets on their chain natively issued on the rollup itself. So these assets, the biggest chunk of the TVL of these chains actually do not come from Ethereum anymore. Even though like this was like how most of these things were designed at the very beginning, these chains have the highest percentage of the TVL issued on the chain themselves. So like on Base, it's mostly like USDC, for example, and the issuer is actually Circle on Base and not Circle on Ethereum and then bridging into Base. It's like directly issuing on Base. And there are some where this percentage is over 90%. Now, this is another set of chains, like Rhea is, for example, Perpdex, that is working together with us on Gelato. Bob is like a Bitcoin L2, also on Ethereum. Mode, Inc. is also a sort of L2, is working together with us. So what do those have in common? Well, the majority of the assets for those chains is actually bridged in from other chains, not Ethereum. So they don't use the canonical bridge that is enshrined to Ethereum to bridge over these assets. They bridge them over from all sorts of different other chains, maybe Solana, maybe Base directly, maybe Arbitrum directly. So these, TLDR, they are using these rollups quite differently than they were designed, if you look at this. And this is kind of like a snapshot of like the entire sort of rollup space. You see that for all rollups that exist, or for all L2s that exist, 47% of all the issue assets are already natively issued on the chains and not on Ethereum anymore. Ethereum is not the asset issuance platform that we thought it would be at the very beginning. Like the dynamics have changed. And what I basically sort of want to sort of make you think today is, okay, if that's the case, if already 47% of all the assets are issued on these rollups, could you make the case that these rollups today are already 47% sovereign and actually not Ethereum L2s, or they are only to a very small percentage, 38%, still Ethereum L2s. This is kind of like how I sort of like want you to think in this presentation. So we analyzed a lot of chains. We worked together with a lot of these chains, right? And when I talked to them, when I asked them, okay, what are you actually looking for in building your ecosystem, your application, your blockchain, they usually come to me with like 5 things. One, of course, very simple. I want extremely high throughput. I want low cost, right? And even today, a lot of the chains that exist do still have pretty limited throughput. Also, transaction fees sometimes go up, especially if Ethereum data availability, Ethereum blob space is filled up. Then the second one is pretty important. It's they want to onboard users very easily to their own ecosystem. And they want to do it fast and cheap. And the problem is, every single time you need to force someone to go via Ethereum to join your chain, you have to pay pretty hefty fees, and it becomes quite slow. That's why a lot of new chains actually want to onboard users via existing rollups or existing other layer, chains like Base or Ink, for example. Then, of course, you would like to have access to like all the liquidity in the world. You want high security, low cost. And this is also interesting. You want more control over your chain. This control means you want to control how transactions are getting sequenced. You want to control how blocks are being built. And there are actually applications and organizations that want to have control over who can transact on their blockchain, right? Ethereum is a lot about censorship resistance, so everyone can always transact. You can never stop them, right? But if you think about like companies actually like building products that want to interface with Web3, then they need some sort of permissioning because they have to be compliant with a lot of things, right? And they might not want to allow the Lazarus group to execute some transactions on their rollup, especially if they are the biggest application on top. So are these sort of L2 assumptions that we set out at the very beginning still valid? Well, after like talking to a lot of developers, I think, and it's sometimes the brutal truth, but I don't think they care that much about scaling Ethereum. They care about scaling the application, right? Ethereum is like a platform they can use in order to achieve this, but it's not about scaling Ethereum per se anymore. It's about, hey, I want to create a successful application in the space. Also, like bridging changed a lot. Like back then, there were like Ronin bridge hacks and so forth, but these days you have pretty solid like interoperability, cross-chain messaging protocols that have a variety of different security modules that can be ZK, optimistic ZK, or just like attestations, like Hyperlane Layer 0 that are pretty robust if you look at like the TVL and sort of throughput they support. Then users actually onboard mostly via stablecoins, especially like USDC. And USDC is still issued on Ethereum, but it's also natively issued on Base, Arbitrum, Solana, and so forth. So if you want to onboard users, you probably don't want to go via Ethereum. You just issue USDC straight on Base or on Solana, then you bridge from Base and Solana to your chain, and bam, you got your user onboarded. Why would you go via Ethereum? It's slow and expensive, and it's not more secure, because the settlement layer for USDC is Circle servers. It's not Ethereum. It's not a native Ethereum asset. Yeah, and so this is sort of like what we came up with after looking at all of this. So we believe that there's this world where there's this big industry which is like, we want to scale Ethereum, and we want to build this sort of like network extension layer on Ethereum, which there's a lot of traction already, and I think it's working very well. But I think from talking to a lot of customers, I think a bunch of chains, a bunch of projects actually do not want to scale Ethereum. They would rather just build and have control over their own blockchain that can interface with Ethereum, but Ethereum is not different to like a Solana to them, or like even a Ton, or like a Base. It's so like all equal, and this is really what the ABC stack tries to achieve. It tries to be this, like it tries to cater to this audience, and it does so at a really impressive performance that I will go into in a moment. And so the design philosophy of ABC, what it is it's an app-centric stack. It's not an Ethereum-centric stack. So rather than having this application Ethereum in the center of like your solar system. You have your application at the center, and Ethereum is just a very large sort of planet hovering your own planet, but it's not different to any other planets like Solana or Base or Ton, for example. You interface with them all the same. It's much more like a mesh network design than it is like a hub and spoke. You can think of more like the Cosmos sort of like architecture and design pattern than like the sort of like L1, L2, L3 pattern. And what it focuses on really is it basically completely gets rid of an enshrined bridge. You cut it out completely. You don't have that anymore. There's no opinionated way to settle to a specific chain and define your rollup based on some light client that you enshrine. But it basically is just, hey, you bring the interoperability system you want. You can bring a hyperlane with like an attestation service. You can bring layer 0 that secures your chain with Google. You can bring Circle if you pay them a lot of money, right? It's completely up to you how you want to interoperate, with whom you interoperate, and what's the security you would like to have. Now, we have some pretty good performance on the stack. So it does 1 gigahertz per second with a throughput, which is sort of like 100 times that of like most other sort of like technologies that are currently available. It is very much based on Celestia. Why Celestia? Celestia as a DA layer has the highest throughput already today, has one single slot finality, which is great for interoperability, and basically from a roadmap perspective will already provide capacity that is way higher than what Ethereum will probably achieve in the short to medium future. Though, of course, I still want Ethereum to scale a lot, and I'm rooting for it. But yeah, I think they have to increase the pace a bit to compete against guys like Celestia here. There's this nice chart with the banana zone on the top right. This is like the gigagas banana zone, which ABC Stack is on. And yeah, you see like versus Base today what type of throughput is possible. So you can really like bring everything on chain that you want. This goes into the modular interoperability. As I said, ABC has multi-chain settlement. So you don't settle to you don't have an enshrined settlement to Ethereum, which defines your rollup. You just have a modular interoperability protocol. You can settle to 6 different chains at the same time, but like you are still like a sovereign chain. And how you want to deal with bridging is completely up to you. And yeah, so this is, I think, how we think of like rollups in the future. They want to directly interoperate with all these ecosystems, and they don't just want to be like connected to one of them and then have this be the asset issuing platform. You want to have assets that are issued on Solana. All the meme coins should come to your platform. Ton, who knows if it will still be successful in a couple of years, but if so, you probably want to be interoperate with it, right? So this is kind of like the architecture more that ABC embraces. Some other really cool features that it has that I think is very powerful based on sort of customer feedback that we heard. One is custom block building. So you can define your own block building rules on the stack. You can avoid MEV. You can update Oracle prices at the top of the block. Or pretty interesting for enterprises, you can say only certain users can actually transact on the chain and can bridge assets in and can bridge assets out. We don't want anyone who doesn't comply with these rules to interact with us. And this is actually how I see the future. We'll have all sorts of companies deploy their chains. They all have to adhere to compliance on like different countries and so forth. But you always have these neutral chains and neutral layers like an Ethereum or other chains to still go to and then enjoy full censorship resistance. So I think they are just like different sort of products, different use cases. Then you have a native gas token capability, and this is not a custom gas token. So this is not like a token that you deploy on Ethereum and bridge in, and you can use it for gas. This is a token that you issue on the chain and use for gas natively. So it's like Ether on Ethereum. It's truly native asset. Then of course it's 1-to-1 EVM compatible, so no changes at all. And it's ZK forward compatible. So you can just like click a button, you can upgrade your bridging security to ZK right away if ZK becomes fast enough and cheap enough, which it is not today, unfortunately. We ran these things in production, but I'm pretty hopeful that with the work of all these amazing teams like Rizero, Succinct, and all the other guys, that we will get there sooner rather than later. So yeah, it's already forward compatible with that. And just like as some examples here, how you can sort of take the stack and make it yourself. If you have a DeFi chain, let's say, how would it look like? You have DA, Celestia. You have interoperability, use like the hyperlane messaging protocol. You want to have high security, you have 500 million in the bridge, well, use Succinct or REST0 to verify bridging transactions via ZK, and you probably want to be connected to Solana, Arbitrum, and Ethereum because they're the highest TVL chains in the AVM ecosystem, right? Let's say you're a gaming chain. Should a gaming chain be like ZK right now? Probably not, right? Probably it has only 500K in TVL. Probably it just wants to mint some weird ass NFTs. So I think having like a 3 out of 4 multi-sig sort of like attestation service to bridge these assets in and out of this chain is totally fine, right? If you can cut costs down and if you can get latency down of like bridging in and out, which is what games want, perfectly fine, right? And you probably don't want to be connected to Ethereum. You probably want to be connected to Ronin or Base or some other ecosystem, right? Yeah, and like finally, like enterprises, as I already mentioned, you probably want to be OFAC compliant. You want to probably blacklist Lazarus. You want to not have them be able to interact on your chain, right? This is all possible, and you probably don't want to post your data to any public DA layer. You want to keep it private. You might want to use ZK to verify that everything has been run correctly, but that's it, really. Yeah, so ABC Stack is now available on our Rollup as a Service platform among the other like leading rollup stacks in the industry. You can actually literally click it in 5 minutes. So like you come to a website, you click a button, 5 minutes, you got the chain. Like the fastest deployment in the industry. I guarantee that. Yeah, so ABC is really for building everything in on-chain and how you want to, and not being opinionated based on sort of some legacy way of thinking about you as an application or a project. If you want to build, come to us, come to me after the talk. We have a booth as well. Yeah, we'll of course love to support you. Thanks a lot for listening in.
Clicking through blockchain debris. Crypto notes flutter like drunk bumblebees.
Dollar will dramatically lose its purchasing power. The more they print, the more it gets diluted. Who it's good for is the people at the tippy top.
Because in order to keep the system going, they have to keep printing money.
And Bitcoin is that tool that allows us to beat the money printer.
Bitcoin is powerful in a way that is money that does not discriminate.
Bitcoin is built by the people for the people.
Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs dial up found. Old to speak, young as each block mine down. Professor Wade's got the future on spin. Urging notes, dancing where the bottlenecks been. Professor Wade's got the future on spin. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, Pete John's got just dreamers, on-chain truth, no middle schemers, working hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing, while the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash, but we don't need your central banks. Regen biddlers stacking stacks. For we bid let this city on force and chains. We bid let this city with regen brains. We bid let this city on force
and fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Work marmots on the scene, you know we're gonna bid a little it there. Some tread vibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay, let the city on sports and chains. We pay, let the city with regen brains. We pay, let the city on sports and chains. No rug pulls, just pure on chain. Chains.
What's going on, y'all? Oh yeah, now we're online. Let me get some hands. Shout out to all the massive crowd. Let's go. Yes, appreciate it, y'all. What's going on? My name's Ben. I work on a project called Optimism. But really, I think for the purposes of today, I work on a project called Ethereum. So really, I'm zooming way out here. I'm not going to spend any time shilling or talking really about what Optimism is building. I want to talk about where I think we are at as a community, as a network, as Ethereum. And I think, especially if you go to the, vast echo chamber that is crypto Twitter and the rest of social media, I think there's a case being made that Ethereum is going through an identity crisis at the moment. It's kind of like a bunch of fragmentation and other chains and competitors and L2s and L3s are popping off, and we're having a kind of moment of reevaluation of what Ethereum is and what it needs to be doing. And I think there's some truth to this. On the other hand, I think it's important to say that Ethereum has not been one static thing over the course of its life. And what I think of today that you might call, if you're trying to foot it, a identity crisis of Ethereum is really more like the next progression of Ethereum understanding at a deeper level what it really is. And so I think it's worth taking a second to look at what the history of Ethereum's identity has been. Because again, it has not been static. Obviously, where we started was the launch. And I think if you can say one thing about the identity of Ethereum at its launch, I think you would say it was the launch of the world computer. Like, I don't know how many of you guys have gone and watched the original, Vitalik presenting Ethereum to the world for the first time. But it was like a true mic drop moment. I mean, look back on it and imagine Vitalik getting a standing ovation at Bitcoin Miami from a bunch of Bitcoiners saying, look, it's not just money that we're decentralizing, it's the whole internet. And it was a big deal. At the end of the day, it was definitely underspecified. Scalability is something we think about a lot in Ethereum. And actually, if you go back to the original Ethereum white paper, you will see actually an entire page dedicated to scaling, which is very interesting. The problem with such a large blockchain size is centralization risk. And actually, if you look a little further and you keep going, you'll see the start of designs for Ethereum that are very similar to the scaling that we see today. This is the quote. I can read it, but effectively what it means is we knew quickly the same basic strategies that actually we're using today. Vitalik was, I think, surprisingly prescient, surprisingly able to look ahead and see that scalability was going to be a problem and gesture at the solutions that we were going to solve. And a lot of what it says looks a lot like the rollups that we have today. At the same time, it was a bit of like, we'll figure it out energy. And I don't mean that as a dig, I mean that as a positive. It's an example of how Ethereum created an identity as the world computer and understood that its identity would evolve as we continued to scale. And I think the next era of Ethereum was the act of figuring it out. There were, I think of this as like the golden age of scaling R&D. You know, ETH research at this time, ethresearch.ch, like the internet forum was absolutely popping. It felt like every day, every week, there were huge, new, exciting developments in the world of scaling. And ultimately, that time period like led to the rest of the scaling, milestones that we see today. And what was really cool about it was that L1 and L2 scaling was all happening in the same place. This research was all coalescing. I think if you look back at early Ethereum roadmaps, it's easy to forget that originally Ethereum was going to do everything. Like L1 scaling had these phases. What is it? Oh, I guess it's, yeah, that's how left and right works. Yes, L1 scaling had 3 phases, which included effectively in the last phase, phase 2, doing what the rollups do today. It was going to be full-on execution sharding. At the same time, there was just like an amalgamation of incredible development in the L2 scaling side as well. And we started with these state channels where we could really scale up the transactions between a few parties. Then we started building these plasma designs, which were very chaotic and messy, and we had like 1 billion of them. But we ended up starting to think about how do we have chains that scale in a layer 2 context, not just these state channels. And eventually, we came on the design of rollups. And what we realized was that rollups were extremely similar. Can you see my pointer? Oh, yeah, I bet you can. Rollups were extremely similar to the execution sharding. And actually, before, it's a very famous post by Vitalik, the rollup-centric Ethereum roadmap. I think it's worth noting that even before we saw that, what we saw was something called phase 1 and done, which was just the general idea that if we scale up the data, rollups maybe can take care of the rest. So this was another era of scaling. Like, I truly think that in this time period, we were laying down the fundamentals of what it would mean to scale Ethereum and how we were going to go about doing it. And it was absolutely incredible. And then we figured out monetary policy was going to become important. The ETH is money era, the ultrasound revolution. This was a big deal and remains a big deal, but it was really birthed during this era as we started to think about the monetary supply of Ethereum. And obviously a huge motivating factor behind that was the EIP 1559, which is the idea that, oh, hang on a second, we can take all these transaction fees that users are paying, and actually a lot of that can be burnt as ETH instead of paid out to validators. This gave birth to, well, we're going to become a deflationary asset, ultrasound money. Bankless had their triple point asset meme. I think unsurprisingly, this addition to the Ethereum identity came at the same time as Ethereum found some of the biggest product market fit that we had seen in all of crypto at the time. It was the birth of DeFi. And like, I just went on Google News and filtered out to this time era and found a bunch of articles. There was an understanding that Ethereum was finding something new in DeFi. It was the kind of movement from the world computer to having an idea of how to scale it, to starting to realize some of the things that it's for. And DeFi was undoubtedly the first big product market fit that we found. So it makes sense that we started obsessing with monetary policy at the same time that decentralized finance became a part of Ethereum's identity. And I think we're in the next era right now, and it's easier for me to go and look back and explain what it is now that it's already been written. So we're writing that history right now. But I think that I would claim is, as we're sorting out these details, ultimately, what Ethereum is doing is expanding its identity and getting a better grip on what its identity is, not fundamentally rewriting it. None of these moments in time were like crises of the Ethereum identity. They were evolutions. And it's a good thing that we're evolving again. It's like there's light at the end of the tunnel. We've gone from an era where we're trying to figure out what the heck Ethereum is for and how the heck we're going to scale it, to like realizing, oh snap, we are actually scaling this thing, and that brings new challenges. But new challenges, new problems are not bad. It's a good thing to have these problems, and it's a good thing for us to continue evolving our identity. So that's a little bit on the history. I think it's worth us as a community, though, looking at where we are at in the present. So I think it's time to do some cold, hard numbers, because what do the haters say? You'll hear that L2s are parasitic to Ethereum. You'll hear that all the L1s are eating Ethereum's lunch. You'll hear that Ethereum is fragmented. And these are valid things that we need to talk about. We shouldn't bury our heads in the sand. We should talk about them. So you know, L2 person comes up and says it's not a parasite, but are L2s parasitic to Ethereum? I think this is kind of the most laughable one of all of the ETH fund narratives right now. It really is really funny. It's like, imagine that Vitalik had posted the parasite-centric roadmap for Ethereum. What could a parasite-centric Ethereum, right? It's like kind of laughable. It's almost ridiculous. At the same time, so obviously not. And one thing that I would add to that is that every competitor to Ethereum is incentivized to say that L2s are parasitic because they are scared of a unified Ethereum. They don't want to see us win together, you know, whatever the meme may be. At the same time, I think we need to take a realistic view of what is actually going on in the world of L2s. They're clearly not parasites. That's just like a laughably ridiculous word to describe. Imagine if Ethereum was still stuck with only one L1 and, you know, it's $20 to $100 transaction fees depending on the day and the same amount of throughput. It's ridiculous. At the same time, we should acknowledge that L2s, again, are an evolution of Ethereum. Like, we have new business models going on in L2s. We have new, you know, EVM designs, new functionalities. We have new governance layers. These things are changing. It's just not in a parasitic way. It's an evolution. I think it's worth also looking at some cold hard data of how Ethereum is doing in the marketplace. Like, is Ethereum's lunch getting eaten? We need to look at the numbers to be able to answer these kinds of questions. And the numbers, I think, overall are mixed. Some numbers are really good. If you look at TVL, we've got 8x more TVL than the next closest L1, knocking it out of the park. If you look at the growth of stablecoin TVL and growth of crypto app TVL, we also are in the lead. Like, we are dominating the backbone of on-chain finance by certain metrics. At the same time, we have work to do, folks. We really do. If you look at DEX trading volume, Ethereum is barely in the lead. It's kind of neck and neck. You know, what's 20% in an industry that is extreme, as volatile as ours? If you look at transaction count, Ethereum, if you include all of, even if when you include all of the L2s, has a third of the daily transactions than the next leading L1. If you look at application fees, we have about half of the application fees being generated as the next leading L1. We need to acknowledge that these are real things. Numbers are hard, and like, you know, you could argue back and forth a ton about how I came up with these numbers. And one of my calls to action on this presentation will be help with the numbers because they're really tough. So putting that aside, is Ethereum's lunch getting eaten? I don't think that's obvious. Could Ethereum's lunch get eaten? Absolutely. I don't think we should put our heads in the sand and deny that that's possible. And you know, to address the last narrative of the three that I started out with, is Ethereum fragmented? I mean, go and use Ethereum and you tell me. First, you got to go and switch your networks to the L2 of the new app that you want to use. Then you've got to take your bridge tokens and you've got to wrap them into a bridge token and send them over the bridge. Then maybe you have to unwrap them into the native token because, oh, and then wait, I forgot I need to have gas money, so I need to go get some ETH. Oh, or maybe it's a custom gas token chain, so I need some other asset. I mean, it's a mess, right? From the developer side, you have different smart contracts can behave differently on different chains. You have different transaction types. I mean, the list goes on and on and on. Is Ethereum fragmented? Absolutely. Absolutely it is. And again, this is something we need to address. And I want to be clear. I hope you all appreciate this AI-generated version of the trade offer meme. I want to be clear. This was a good trade for us to make. I don't think we would be in a better spot as a community, or Ethereum would be in a better spot as a network, if we didn't make this trade-off. What we said was, we're going to let the L2s run with it. They're going to give us huge throughput gains, way turn down the cost of transactions, and we're not going to have to sacrifice decentralization along the way. But that doesn't mean that everything was free. The money Legos, which were that product market fit in the era of, you know, ETH as money and the ultrasound revolution, those money Legos were key to that story. And it is just harder to put together the money Legos when they're spread across the Ethereum ecosystem today because the boundaries of chains are tougher to cross. So that's a little bit on where I think Ethereum is. I think Ethereum is doing really well. I don't think we're having an identity crisis. I think we're evolving our identity and peeling back the next layer of the onion. At the same time, there is serious work for us to do as a community. So what do we need to do as a community? One thing that I've been harping on, and I'll harp it on you again, is we need more robust economic models. You know, if you look at the incredible work by John Charbonneau and the DBA team, they've built out this TEV, REV framework where we start to look at what does it mean to have a proof of stake network like Ethereum? What does it mean for it to have issuance? What does it mean for it to be paying things to validators? What does it mean for it to be taking in fees and burning them? There's some really cool work going on that's like a kind of a 0 to 1 moment. But at the end of the day, like looking at ETH, the asset, and how much ETH is going in and coming out to the different stakeholders is a tiny sliver. It's like you know, a single measure, like the surplus or deficit of a country. It's like we're looking at one part of what is Ethereum, when in reality, Ethereum is a global network of economic actors, and with the birth of L2s, it's a global network of L2 networks themselves. Like, the graph is immense. And we're basically, when we look at just something like TV or REV in Ethereum, we're effectively looking at just one measure when we could be looking at an entire GDP. And you know, as a matter of fact, it's like more than that. There's like layers upon layers of these economic relationships, from the users to the apps, to the infrastructure, to the wallets, to the block space itself. These are incredibly complex economic flows. The data is there, so much lives on chain, but we need to do a better job modeling and understanding what the data actually says. Because I got news for you. There's probably 10 things that were wrong in the slides and the graphs that I showed. And the only way to figure that out is for us to dive in and read the data. Another thing that we need to do critically is we need to gain back the network effect. We need to defragment. Ethereum is absolutely fragmented. And the good news is, on this front, a lot of awesome work is happening. I think that 2025 will be the year that we kill Ethereum ecosystem fragmentation. Intents and the ability to send funds across chain in a much more easy way is going to be a huge piece of that. Account abstraction, the idea of killing network switching and making the wallets actually work because they were all built for one chain and then we introduced 1,000 of them, is going to be huge. And then a variety of interoperability protocols on top of that need to happen. And with these tools, we will make Ethereum feel like one chain again, and we'll have all the advantages of having many without those downsides that we made in the original trade offer, as you will. At the same time, we need to continue being the leader in decentralization. The reality is, if you go to L2 Beat, there are 4 out of hundreds. There are 4 chains that are stage 1 decentralized. Even stage 1 in some ways is a glorified multi-sig, but stage 0 is a real just multi-sig security model effectively. The reality is that's still better than any other community, right? We still have the 4 stage 1 chains, but that number needs to go way up across the board. At the end of the day, part of the, if I go way back and you regret my life, part of what we were doing was getting gains without sacrificing decentralization. And we've done that to some extent, but we need to lead there. We need to lead. And I'll also say that there's some really awesome new designs coming out in Ethereum research. These are ETH research screenshots. Maybe we're returning to a second gilded age of ETH research, building based and native rollups. And I think, I don't have a lot of time to really get into these topics, but I think if you know what they are, the plea that I would make to you is to understand that these are incredible superpowers that we will give to the L2s. The reason to do that is to make the L2s better. It is not to recoup a bunch of ETH back to Ethereum, back to L1. So my plea would be, don't let economics of these things kill the feasibility. The reason that native and base rollups are going to be valuable is because they make L2s better, and that makes them get more adoption, not because it returns the bag to ETH and exclusivity. Last but not least, we need to scale. You are just not bullish enough on the future of the world computer if you think that what Ethereum can handle today is acceptable, even with all of its L2s. And even if you look at the most well-specified parts of the dank sharding roadmap where we increase the transaction throughputs, still, I don't think you're bullish enough on crypto and on the world computer if you think that the entire decentralized internet is going to run at the kind of scale that we're talking about here. So we need to keep scaling. And we need to do it quickly, too. Like, one of the failure modes could be we figure out how to scale Ethereum, and then it takes years to actually get those upgrades released into prod. We need to actually be able to act as we build out better and better and better features. So BPO forks, being able to fork just to increase the number of blobs is one approach. Vitalik says just let the stakers vote on it. I'm down, let's do it. But we need to come up with something here. So just to wrap it up, I think what I would say is the most important thing that I want you to take away from this presentation is don't believe the fudders. Everyone is incentivized to say that Ethereum is fragmenting and falling apart and has came up with a parasite-centric roadmap, and that's just not true. What is happening is Ethereum is peeling back the next layer of the onion. It's coming to understand the next part of its identity, and that's a really, really good thing. And I think it's undeniable that we have to accept that the role of layer 2s are to steward and carry that torch forward. And to do that, we need to do three things. We need to unify, we need to stop infighting and make everything, all of Ethereum, feel like one big chain. We need to keep decentralizing and remain the leaders in that field. And we need to ship the upgrades that will scale these things to the next billion users. So that's all I got. If you want to contribute to the data, come check it out, scan that QR code. We're putting it all together. It's going to be great. Thank you very much. Appreciate it, y'all. Woo! There we go. I know I screwed up when you were supposed to applaud. It's my bad. It's my bad. Thanks, y'all. Appreciate it.
Dollar will dramatically lose its purchasing power. The more they print, the more it gets diluted. Who it's good for is the people at the tippy top.
Because in order to keep the system going, they have to keep printing money.
And Bitcoin is that tool that allows us to beat the money printer.
Bitcoin is powerful in a way that is money that does not discriminate.
Bitcoin is built by the people for the people.
If your chain's choking ether night whiz, found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies, scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with you ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I scooped and truce from trash sheets. That's my device. Nullify into your list tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Rock on the island, toolkit homemade in 7/4 Shaboom, dose, the efficiency pulse. The lag runs lagging in his latency so.
What's up, everybody? Thank you so much for coming to my talk. My name is Kevin. As you guys mentioned or heard, I work for The Graph as DevRel engineer, and I also support the Build Guild on Scaffold ETH. And today I'm going to be talking to you guys about how you can build your first application on Ethereum. We'll try to do a demo if we have time. Let's see how it works. So I don't actually have any slides. I just kind of want to walk through some assets for people to get familiar with. The first of all, when I first came into the space, I was kind of struggling with like finding the right tools. There's so many different tools out there these days to like accomplish the same thing. And it was a kind of a long journey, but eventually I found myself actually to Scaffold ETH. It was kind of my entry into Ethereum. Because it really provides everything you need out of the box to get started quickly on building, and it also is really great for hackathons because you can spin it up, prototype, and basically iterate really quickly. It's built on Next.js, so it's React with Next.js. It's all TypeScript, which is amazing, and everyone should be writing TypeScript. And it's also integrated with WAGMI and RainbowKit, and it's got a huge community behind it. So we're going to spin it up in a little bit, but I want to kind of walk through a little bit some other tools. Another thing you can look at is Cookbook.dev. Cookbook.dev is just a great resource if you're just starting into like writing smart contracts. It's a good place to find like starting smart contracts. So on there's a lot of Open Zeppelin contracts. If you just do a search for Open Zeppelin, you should be able to find all the Open Zeppelin standard smart contracts. And you can also spin them up inside of Scaffold ETH, which is really cool. They have a direct integration. The internet's a little messed up here. But you can go to the homepage, and you can go to Cookbook, and you can basically look at contracts. Here we go on the top right, if it loads up. I don't know why it's not loading. Okay, well, we'll give it a second. But yeah, any kind of like ERC20, ERC721 is available through there. There's also some examples of like just whatever you want to build, staking contracts, stuff like that. And inside of each contract, you have this option to open it in Scaffold ETH. And you can actually download the entire project, and it will be a Scaffold ETH project. And all you need to write is the deploy script, and you can kind of have a good starting point. So it's a great spot to go. Sorry, the site's not loading. Another thing that everyone should be familiar with is Speedrun Ethereum. Speedrun Ethereum is a great tool for like when you want to validate like what you've learned and like being able to implement this into like a real world scenario. And so if you go to speedrunethereum.com, you can come on here, and there's a series of challenges that you can go through, right? So the very first one is very simple. It's kind of a no coding kind of challenge. Like you don't have to actually write any smart contracts. You deploy an NFT, and it teaches you about how NFTs works, teaches you about Scaffold ETH as well. And it's just kind of a fun little first entryway into Speedrun Ethereum. And then you get more difficult. You learn how staking works, right? Like how does a staking contract really work? You learn about how to do like swaps, like with a token vendor where you like deposit some asset and get back another asset. And then you start learning about randomness in a dice game, which is like kind of teaches you that on a blockchain, there's this kind of whole other level of like randomness that can be gamed, and it's kind of just a real good example of that. And then eventually you build a DEX, right? You get very much like kind of down the rabbit hole on like how a DEX works, how liquidity pools work and stuff like that. And after you do these challenges, you actually join the build guild. So anyone can be in the build guild. And you have some special Telegram chats where you can work with other devs on building. Eventually, there's some other ones like stable coins, which is actually a new challenge, really cool. Prediction markets, another new challenge, which is, prediction markets are really hot right now, so you actually build one there. You learn about deploying to a layer 2. And you learn about multi-sigs and SVG NFTs, which are like our more advanced NFTs. So there's lots of fun stuff you can do in there. Another cool thing that I've been working on for the last few months, I work obviously for the Graph. I'm also in the Build Guild, and so Speedrun Ethereum has been like a very influential part of my experience coming into the space. I created a new platform called Graph Builders Basecamp, which is kind of aimed at the same kind of scenario. You're building writing smart contracts, but this actually teaches you and validates your experience on how to write subgraphs on the Graph network as well. So if anyone here is interested in like the Graph and like data, this is also a really good. And I have a video that I'd like to play for this, so you guys can check it out. Huge shout out to our design team at the Graph who created this. Awesome. So yeah, you guys can check that out. You can go to basecamp.thegraph.com, and there's a series of missions you can do up here on the top left. They range all the way from like, again, very basic, like an orientation mission, all the way down into like more advanced subgraph development. And after you do each one, you actually get an NFT. So you mint this kind of like on-chain soulbound NFT. That kind of like just verifies, that you've done it. The cool thing is this entire platform is also decentralized. It's utilizing smart contracts, and it's all built on Chainlink functions. So you can technically spin up this project, which is a GitHub project, and you can run all these on your laptop. You don't even actually have to connect to the basecamp.thegraph.com. Because you're using smart contracts and the Chainlink decentralized Oracle network to mint those NFTs. So really cool use case of the Graph as well. And if you look on like the Build Guild website, so like if we go to the Build Guild, right, and we go to the app, and I connect my wallet, so here's me. You can see that I have the build on there. So my ENS is cryptomastery.eth. And so if we click on that, there's a link to the live demo, and then there's a link to the code. So you can come here and kind of see what it is, how it works, and you can spin it up on yourself as well too and check it out. So please do that. But let's get into some coding. Let's see, we have 13 minutes to go. Let's see if we can push a application out really quickly. So we're going to use Scaffold ETH. So we're going to go to scaffoldeth.io. We're going to grab this npx command, which is basically like a script that you can run that gives you this kind of like choose your own adventure to spin up an environment of Scaffold ETH, right? So we're going to do npx create ETH at latest. We're going to choose a name. So we'll just do ed for like ETHDenver. It's going to ask you what framework for your chain that you want to use. So we support Rahat and Foundry. So if you're new to writing smart contracts, Rahat has been around a lot longer. I recommend that. It's probably easier to find like documentation. If you just want to write your smart contracts and tests in Solidity, Foundry is a good one for that. It's a little faster. It's a little newer. You're really up to you. I'm going to choose Rahat. It's going to kind of go through and install all the dependencies for you. So it is a Yarn package. So it has a package JSON file. It's a mono repo, and it has everything defined for you. So this is going to spin up all the proper packages for you, and then it's going to format the files for you and all that good stuff. I've actually already did this to save time just because of the internet connection. So I have a directory called ETHDenver here. When it's finally done, you'll get this output that says, okay, are you ready to get going? We need to spin up a chain, we need to deploy our contract, and we need to start the front end. So that's exactly what we're going to do, is we're going to do yarn chain, which is going to let me spin up my Rahat. We're going to go over here. You always need a couple windows open with Scaffold ETH. So you can just do this in separate terminals. It's up to you. I use tmux, which is just easier. And we're going to spin up the front end. So we have this virtual chain on the left. We have our front end on the right on port 3000. And then now we can go into this last directory, and we can do our yarn deploy. So all of these commands are yarn this, yarn that. It makes it really easy to orchestrate. Now we've deployed a contract to our hard hat node, and we get a contract address, and we get some gas, and everything's good. We have some console output, and you'll see this last line is the most important thing. It created a special set of TypeScript definitions for our smart contract, which is really powerful because when you're writing in your front end and you want to be able to like interact with a smart contract, using those TypeScript definitions is like really, really awesome because it's super easy. And if we look at Scaffold ETH running on port 3000, we'll take a look and see what it looks like. There's a really cool feature called the Debug Contracts tab. And we go here. It takes a second for it to compile because it has to compile for the first time. So we'll give it just a second. There we go. We're on the wrong network. Let me disconnect. There we go. And you'll see this. This is like your Hello World page. Kind of can ignore this. This just kind of gives you some hints. But here in the Debug Contracts tab is where the real magic of Scaffold ETH is it has this ability to ingest those types and just build this kind of UI for us, which is really cool because then we just know how we can test our contract without having to write any front-end code, right? So I can tell right now that this contract has a string called greeting. It has an owner, which is an address. It's got some like a Boolean, and it's got a counter, and it's got a read function and a couple write functions, right? So it's really easy just to know what's going on. I haven't even looked at the contract. But let's change the contract. So we have this like building unstoppable apps. We can try to change the greeting to something else because we see there's a set greeting function. So let's call it ETHDenver. Boom, 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 and try to send. It's going to tell us we don't have enough to pay for gas. There's a built-in faucet. So you just hit this little faucet button. It will give us some funds from the faucet. Then we can hit send again. And there we go. We updated that state variable to ETHDenver, right? So we've kind of like messed around with the contract. We get a receipt, transaction receipt that has all the response. We can also pay some value if we wanted to. Like if we do 0.01 ETH, you'd think you could just hit send, but we need to contract or we need to send it in Wei. So there's this cool little function here that allows me to translate that to Wei. And then I can hit send, and there we go. Now I got some money in the contract here. There's $22.67 in the contract. But there's this withdraw function. Can I withdraw the funds? No, probably not. It says I'm not the owner, right? Because I've kind of protected this. We know that this has some kind of protection because it's probably like blocking me, right? It says, no, you're not the owner. You can't withdraw those funds. So let's look at the contract real quick. Let's open it up in VS Code or Cursor, whatever you prefer. So we have VS Code here. We have our packages folder. So Scaffold ETH is basically, this might be hard to read. Let's see. It's 2 folders in the case of like a standard install. I will tell you that there are extensions with Scaffold ETH, which are really cool. And one of those is called the subgraph extension. That's actually how I built the Graph Builder Basecamp, is using the subgraph extension, which has a built-in like the graph functionality to spin up the graph. But then there's other ones too. So you might want to use an extension, and if you do, there might be additional folders. But in this case, we're just doing the standard kind of Scaffold ETH setup. So we have our chain and we have our front end, right? Those are the 2 folders that we'll spend most of our time in. Inside this packages hard hat folder, there's a contracts folder, and then there's our contract. So we have this kind of starting contract. It's basically exactly what we just saw, in the UI. So we could probably make some changes here. So what I'd like to always do is kind of just like make one simple change. Like let's do address, public, the boss. We set a boss. And then maybe we want to have a function to like update who the boss is. Set boss, something like that. There we go. So we have this kind of new variable we're adding, right? And then we have a function to update the boss, right? And then we're going to pass that in as a string, or as an address, sorry. And so if we want to deploy those changes, we can come over here and just do yarn deploy again. It will push the new changes to the chain. We could also force a contract. Like if you need to like make sure you get a new contract for some reason, you can do a -- reset and it will force a new contract. Just kind of a nice little neat to know. And then if we go back to Scaffold ETH now, it will refresh and we'll get that new boss variable, right? So we have this boss and we can set who the boss is. So let's set it to Vitalik.eth. Boom, he's the boss. All right, there we go. So now Vitalik is the boss. And you can see it's got this cool like ENS resolution. It kind of shows us, it's got a little copy paste thing. And so this is cool for like testing. You know, you make a smart contract change and then you publish it. But maybe you want to like edit the front end, right? If you go to Scaffold ETH and you go to the docs, there's a whole section on components. So everything you see in the Scaffold ETH, like the little address component that has the ENS resolution and the copy button is there. There's a balance component that lets you switch from ETH to dollars. There's an address input field that does ENS resolution, so you can put in an ENS. And then you have the ability to interact with the contract as well. So if you want to read from the contract, or if you want to write to the contract, there are existing hooks in React that let you do that. So it's super fast. You don't need to like mess around with writing your own hooks. They're there and they work great. I mean, there's a whole bunch of apps that have been built on Scaffold ETH that are really, really great. So I'm not going to do any of the front end stuff because I only have 5 minutes, but let's try to deploy this to a test net. So at this point, we don't have a deployer account because we've been using these keys that come with Hardhat, so we need to generate a deployer account. So we can do yarn generate. That's going to spin up basically a private key and a public key pair and store it on my machine with a password. So let's do that. There we go. It creates a public key right here, which is here, and I can fund that. So, and I can, if I want to look at, see what my balances are, I can do yarn accounts, and then I can put in my password again, because we don't want to keep private keys laying around on the machine. And it gives you a little QR code, and then it goes through and checks all the balances. Let's just send some funds there real quick. So I'm going to use MetaMask. Let me grab the address again. Let me just send base Sepolia. Yeah, Sepolia. So Sepolia. I have a lot of Sepolia here. Let's send 0.25. Sure. Confirm. Cool. So I just sent some funds from my MetaMask to this deployer. So if I do yarn account again, it might take a second. So actually, you know what we'll do is let me do it one more time. Yarn account. See if it went through. There it goes. So now we have a balance of 0.25. So now if I want to deploy to Sepolia, I can do yarn deploy -- network. Sepolia, and this will push it to Sepolia. That's it. It's going to ask me for the password one more time because I need to sign a transaction with Hardhat. It's going to compile my contract. It's going to create the transaction for me, and it's going to push the contract, hopefully. It's a little slower, obviously, than localhost. And then while that's doing that, we need to point our front end. There it goes. It was successful. We have the contract deployed. We need to point our front end at Sepolia. So let's go back to the project, and let's come down here into the Next.js folder, and let's look at the scaffold config file. It has the chains dot whatever. So we can do chains.sepolia, like that. This is basically the target network. So it does the chain ID, and it figures out what the RPC is automatically built with the built-in types. And so now if we go to Scaffold ETH, we can load it up. Let's get refresh real quick. And you'll notice we get kicked out of the burner wallet. So before with Scaffold ETH, you have this cool little burner wallet that's built in, and we didn't have to connect to MetaMask. But because we've published to a testnet, we need to actually connect our wallets now. So let's connect it. Boom, there we go. And then there we go. Now I have the debug contracts tab, and it's pointing to Sepolia. And I don't have a boss set. I could set it to Vitalik.eth. Send. Boom. There we go. So I've deployed the contract, updated my front end. Probably the next step would be I'd want to publish my front end. You could publish it to like IPFS or some kind of like decentralized network. But we do have or like Fleek is a good option. But we have this built-in ability to publish to Vercel. So you can do yarn Vercel. I think it's Yarn Vercel. See, what is it? Yeah, Yarn Vercel :YOLO -- prod. Okay, so what that does is it basically like it'll ask you to sign into your Vercel. It's basically just Vercel CLI, and it's going to ask you if you want to set up and deploy. We do, I think, yes. Do I want to use an existing project? Yes. Found a project. Do I want to use that one? No. Do I want to link it to a different project? No. And then you can just create it. So we can do ETHDenver and hit enter and no. And there it goes. So now I'm uploading my front end to Vercel. So in a few minutes, this will be available. If you have Vercel, you probably need to log in and make it the deployment public. But from this point, we basically built an app pretty quickly, like within 10 minutes. It's not a cool app, it's just something silly. But using Scaffold ETH, you can see how you orchestrate very easily using those built-in commands. So I hope that was useful, and I'll be around here. So if you guys have questions afterward, I would love to answer them for you. But the TLDR is use Scaffold ETH, speedrunethereum.com, and basecamp.thegraph.com. All right, see you guys.
Shaboom goes the efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spin, urging nodes dancing where the bottleneck's been. Professor Way's got the future on spin, bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto nodes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, urging nodes dancing where the bottleneck's been. Professor Way's got the future on spin, bugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Orders just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Lag runs dial-up found. Age? Old as speak, young as each block mine down. Professor Way's got the future on spin, urging nodes dancing where the bottleneck's been. Professor Way's got the future on spin, bugging tomorrow with yesterday's RAM stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he just got just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause
floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we bid let the city on sports and chains. We bid let the city with regen brains. We bid let the city on sports and chains. No rug pulls, just pure on chain. If you faded, just stay seated. The Etherverse will leave you heated. We don't need your legacy, cause regen memes are upgrade. Big let the city on sports and chains. We big let the city with regen brains. We big let the city on sports and chains. Rolling up and slapping.
All right. Today we are going to be talking about the token search. Are there any designers or people interested in design in the room? All right. There are a few. All right. So today we are going to be imagining, ideating. This is a non-technical talk, so turn on your design senses and let's get started. Before we start, let me introduce myself. I'm Simon. I'm a principal designer at 0x and Matcha. Matcha is a text aggregator built by 0x, and we are enabling users to swap across 9 million tokens, set limit orders, and perform cross-chain swaps. All right, tokens got really complex, and so does the search. So let's start with talking about token search evolution. All right, 2017, the rise of the ICOs. There were many interesting projects coming out, and the trust of the tokens was mostly built around the founders, their white papers, and the things that they delivered. And the search was not really in a bad shape in 2017. In 2021, that's where we've seen layer 2s. They came here to solve some of the Ethereum's issues like high fees, low speed, and scalability. And we started seeing some bridged coins. For example, USDC. So what happened when you typed USDC into the search? Well, you started seeing two USDCs that are visually very similar. So how did we fix that as designers? We added the chain icon. It was quite easy. But then Circle started issuing their USDCs, and they started looking similar again. So how do you fix that? Some apps started to rename their names, their tickers, and overwrite the original names and tickers of these tokens. And they started sorting them, and this can work for some tokens, but it's not really scalable, as there are more than 6,000 tokens being issued every day. So how did we fix this in Matcha? Is that we introduced the custom issued by Circle badge, and we started pointing on the right USDC. All right, 2025. I call this era and 100x profit hunting a flood of meme coins. So last year, we started seeing new tools being built like Pump.fun, Clunker, or Flaunch that gave basically a tool for all of us to launch a token pretty easily. And with that, we started seeing scams. But this time, like, the scams were here before, but this time is different. As influencers, YouTubers, and politically exposed people started to participate in these scams, people that we should trust. the token discovery. So there are two types of the token discovery. The one is active, and the other one is passive. The active one is, those are the users that are really active in the space. They are active in the Telegram groups. They know all the contract addresses. On the other side, there are people that are discovering tokens passively. They can hear friends talking about it, or they explore it on the social media. And today we'll be focusing on the passive discovery. So user at some point is asking these two questions. Is the token trying to impersonate another token, or could I get rocked if I buy this token? Let's start by answering the first question. So Ethereum is permissionless, so anyone can create a token with a similar name, the logo, or the ticker. So it can be pretty chaotic out there. Let's say I create this new puppy token on Base. This is it. But there are some scammers that created the same puppy token, and suddenly the search is kind of chaotic out there. And so how can we find that which one is my puppy token? Well, we have the contract addresses, of course. But just look at this. It doesn't say anything when it's standing alone, and it's super long. We are not even showing the full length of the contract addresses. So imagine your contacts app in your iPhone. So there are no phone numbers out there. There are just the names of the people that we saved. Now, let me give you an example. Let's say I know 20 Aarons, and I save them as Aaron. And the secondary information I see is their phone number. So how do I determine which Aaron do I want to call to? It will be pretty hard, right? And even though I find the right token, I find the contract address with the passive discovery, it still doesn't mean the token is safe. So now let's go to the second question. So there are many token risks out there. For example, there is no liquidity, meaning you cannot buy or sell the token. The token might be a honeypot. You can buy it, but you can never sell it. The source code is not verified, so there might be some malicious code hidden in the source code. There might be unlimited amount of tokens being minted. And there are many others that we know now, and there will be many others that we don't know. So what are the token trust signals? Is it the market cap? Not really. The market cap can be easily manipulated. So does the volume. The wash trading can often pump the high volume. Is the circulating supply? Well, creators can unlock new tokens from the total supply, and circulating supply is not really a trust signal without knowing the total supply. But even though we know the total supply, there might be still new tokens being issued. Is it the price? Price often goes really high before a rug pull. So does the change. It changes all the time. So what are the token trust signals for you? Well, for this, we need to learn from the best. We like to call this phase, we designers like to call this phase an inspiration phase. So how does Google do it? Like, how come I can always find what I'm looking for? Well, they're using lots of various things, like tracking your history location, tracking your actual location, many other data like backlinks, AI machine learning, and deep contextual understanding. And there are many other things that are hidden under the hood. So what do we have in Web3? Well, we have the liquidity. So we know we can buy or sell the token. We have the number of holders. So we know there's not a large number of tokens in the hands of few wallets. We have the verified code. So we know there is something not sketchy going on. There are other things like if the token is listed on the price tracker or the centralized exchange. So if you bring back the Google result ranking attributes, are there any alternatives that we can use in our privacy-focused industry to improve the ranking? Of course they are. And there are tools that we can use today, like Go+, Squigintel, Block8, or Token Sniffer that can help us do that. Now, let me spend some time talking about the token badges, starting with the warning badge. Warning badge is great. It can warn you for some things that are hidden that you don't see, but the warning badge is not really transparent. It doesn't tell you if those issues are serious or not. And there's the community recognized badge, which is also good, but user is often asking, like, who are people behind this community? Is the community closed or is it opened? Or are there scammers in this community? And there's the custom badge, like issued by Circle that we use in Matcha. But custom badges can get quickly out of hand, so we should be really careful using them because the search can get really busy. And then there's the verified badge. Verified badge is really dangerous. We don't know what verification means. Does it mean that the source code is verified? Does it mean that it's a good investment? I'm going to make money on this? What does it really mean? There are a number of products using verified badges, and yeah, it can go quickly. It can get quickly out of the hand. Like this example, when I'm searching for a Pepe token, and there are two Pepe tokens that look really similar. They have similar name, similar ticker, and similar photo. And there are other examples, like on the Polygon scan, like when there is a verified badge and it says reputation neutral. Some information on this token has been verified by Polygon scan. Click for more info. Some information? What do you mean, some information? You're putting a verified badge there. You should verify all of it. If it's not possible, don't put a verified badge there. So, how to design a perfect search? Let's start with typing Bitcoin into the search. I love this example, and I really test all the searches out there with this example. But you know what? There are some designers over here, or at least you're interested in design. So let's do this together. I'm going to start first, OK? And then I want you to follow. So I would like to put there, let's say, the logo and the chain icon. So what else are we missing here? A ticker, name, what else? Address, contract address, yes, price, yeah, price, liquidity, number of holders, verified source code, liquidity pools, and some badges. And I've heard the banner? Well, I'm not so sure about this. It feels kind of busy to me. And the Z-shaped reading pattern is kind of broken here. And I feel lots of these things can happen under the hood. So let's start again. Let's start with designing the default state for the search. So before the user starts typing. So we need some sort of input field so users can enter what they are searching for. Then let's add the chain selector so they can easily filter across the chains. Then let's add what's the most popular in the app so they know what others are trading. Then let's follow with their tokens. So because it's very high chance that they are going to start trading the tokens they already own. Then the recently searched and the curated trending section. And now let's type Bitcoin again. So this is what we see. On most of the DEXs, wallets, and products out there, we see a Harry Potter, Obama, Sonic, 10 Inu as the first result. Because the ticker of this token is Bitcoin. And there are a bunch of other Bitcoins that are very sketchy, or I wouldn't trust this. So how can we fix this? Firstly, let's remove all tokens that have zero liquidity, because you cannot trade them, you cannot buy them, you cannot sell them. Now, let's remove all the honeypots and those that don't have the verified source code. Now let's consider if they are listed on some price trackers or centralized exchanges, or what's the number of holders of this token. And finally, let's sort them by liquidity. So we've got from seeing some Harry Potters into seeing relevant coins, like wrapped Bitcoins. But we should not stop there as designers. We should know the user's intent. Like, for example, when the user hovers above the token, we can show a quick preview. So, OK, what do we see here? So there is the logo, the chain, there is the name, symbol, the ticker, and there is the contract address. And we have some other elements there. So what are these? So this is the liquidity. And there's also a security audit, which is highlighting the number of issues that this token have. There are some other information that are secondary as well. So have you ever wondered what happens when you type chess into Netflix? Well, as a first result, there will be the Queen's Gambit. Despite there is no chess in the name of the series, but the search knows that the series is about the bat, which became a chess master. So how can we apply this in our Web3 apps? Let's say I'm searching for a Farcaster token, but there is no popular Farcaster token or the token that was issued by Farcaster, but the search should know that there are other tokens that are really relevant to Farcaster, like Degen, Hire, Moxie. There are others. There will be others. Or we should consider the social signals, like what my friends recently sold or bought. This will be indeed a really good signal for me to know that this might be the token I'm looking for. And there are other on-chain activity that we should be tapping into, like my friends, friends of my friends, the wallets that I'm frequently sending on or receiving transactions from, NFTs I hold, or the projects and communities I follow. And this is my favorite. I would love search to understand prompting. So what are we typing here? Give me a list of tokens with 100 plus holders, with 200K plus liquidity, with 0 security issues, launched no longer than 4 hours ago. And I can suddenly see relevant tokens that might be interesting for me. And I will not spend a lot of time going through the detail of the token, so this can really speed up my workflow. So what are the takeaways? The search should be simple, but powerful. The user needs to have protection without additional friction. So we as builders need to force for better discovery and safety mechanisms. And finally, we need to find a way how to verify the security of the tokens much faster, because there might be millions being stolen from users in just the matter of few hours. And this is not throwing a really good light to our industry. We will start rolling some of these features in upcoming weeks in Matcha, but let's build this together for our users across all our apps. Thank you.
Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise. Admin fees are burning. CK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. Chains.
Minutes.
She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moan while Lagron drools over slow motion duel. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a bufficorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. Eyes scooped and truce from dress sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs on the dumpster dive jump. Eyes everywhere, that's 3 burner phones. Chowdhury's whisper, king chomping blockchain bones.
entropy. Mace cracked walls like, who's got the keys? Nullifiers huffing, you're just a rat with as firewalls splinter to confetti bits, I'm curating leaves. After party, sipping tearless tears. Call me well connected, I call it. Guitar slide. Guitar slide.
Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Homemade in 7/4 time. Shaboom, those that fish.
G-Move, y'all. Thank you for coming to my talk. This is Move for Solidity Devs. My name is Rahat. I'm going to be telling you a little bit about what we're doing at Movement, how you can get started building on top of Movement. And yeah, let's get right into it. So I'm Rahat, Senior DevRel Engineer. Been DevRel in a few different places in the Web3 ecosystem for a while. Formerly a hip-hop artist. I don't do that anymore. I no longer take requests for freestyles. I kind of suck at it now, so it's been a while since I've done that. Been a front-end engineer, freelance Solidity dev. So I came into the Move ecosystem from the VM side of things. So some of this is kind of going through a little bit of what I wish I kind of had when I was going into the Move ecosystem myself. So quick agenda. We'll do a quick history lesson on the Move ecosystem in general. A little boring, I'll try to keep it short. We'll talk a little bit, very high level, about the Move virtual machine. We'll have an overview of Movement, how we're kind of like bringing this over to Ethereum. And then we'll look through a couple of code examples and snippets so you can kind of like solidify some of the concepts that we talked about. Cool. So brief history of Move. Where did it come from? Where did it start? A few years ago, Facebook was actually looking at building out a blockchain underneath their social media platform. And that was two teams, or one team, I suppose, DM and Libra teams who were coming in, building out the Move VM, the Move language. And initially, this was supposed to be a chain that powered some of like Facebook's like payment type of systems that they wanted to go into. Unfortunately, at the time, the SEC decided, no, Facebook, you cannot do this. And so the DM and Libra teams kind of like branched out. Some of them went on to become the Aptos chain. Some of them went on to become the Sui chain. So right now, the two most popular chains using the Move language are Aptos and Sui. And over us at Movement and a few other chains are now also coming up with new Move chains. And us especially, we're building out something on top of Ethereum. So before we go into a little bit more on Movement, what exactly is the Move VM? So again, very high level, the Move VM is a runtime that executes Move bytecode. This is similar to the VM, executing Ethereum bytecode that's compiled from Solidity and Viper, but we're looking at using the Move programming language instead. So the Move programming language emphasizes safety, flexibility, and a resource-centric design. And we're going to go into each of these when we go into the code examples. But essentially, it gives you an environment that has a lot of like VM-level safety features. And I'm not going to say it's safer or better than Solidity. That is up to you to decide whether that is true or not. But it does give you an environment where it makes it a little bit easier to avoid some of the common kind of like pitfalls that you might see in Solidity contracts. So for an EVM developer, you can kind of think of the Move VM as a specialized environment in which every piece of data is treated much more rigidly. Particularly anything declared as a resource, and that's going to be the big thing that we focus on today. And the language's design ensures that the assets behave the way that real-world assets do. no implicit copy, no accidental deposital, things like that. And we'll kind of like contextualize that in a bit. So what's movement, and what do we have to do anything here? So movement network, public mainnet soon, TM. That's all I've been asked this week. But very, very soon, keep an eye out for announcements coming out there. But what the movement network mainnet will be, it's going to be a proof-of-stake sidechain on Ethereum. The movement network is the first move chain that is built using the move stack. The move stack is going to be sort of like an SDK and a set of suite of tools that other folks will be able to use in the future to build out their own move chains. Our goal really is to bring the move VM to Ethereum. And ultimately for me, the way that I've been approaching this, at least on the DevRel side, as I've been talking to devs, as I've been trying to onboard them to the move language, is really just this question. Is like, what if we could just provide devs with another environment with some of those safety level features ingrained within the VM level? So let's just jump into some code. So on screen, you'll see just like your basic Solidity greeter contract. If you've onboarded and learned through Hard Hat, you probably remember seeing this contract whenever you spun up a Hard Hat back in the day. Probably one of the first couple of contracts you've ever maybe looked at as a Solidity dev. So we're going to take a look at like how this converts over to Move and talk about some of those like concepts of safety as well. This is what the contract looks like written in Move, so slightly bigger. We're going to be going through some of these in a bit. This does have a couple of additions, a little bit of error handling, and a few other things in there that we'll be talking about in a second. Has a couple tests written out in there too. So, well, how do smart contracts actually work, right? So in the Move VM, actually, before I continue there, one thing to kind of note, I mentioned before that the major players in the Move ecosystem have been Aptos and Sui. Both of these companies have slightly different variations of Move. At Movement, we use the Aptos Move VM. So if you are coming from the Aptos ecosystem, we're pretty much one-to-one with their tooling. So if you know Aptos Move, you already know how to build on Movement. So modules and smart contracts. So modules are smart contracts. A module is published at a specific address. So for example, 0xmy address will have a specific module. It can have several modules in there. It's kind of like one of the first things I had to kind of like conceptualize myself. When you're looking at the EVM Solidity side, when you deploy a contract, each contract has its own address. It's slightly different on the Move side. Rather than each contract or module having their own address, you're deploying specific modules to an address. So you have your deployer address, and you can essentially deploy multiple modules to that address. So users store what are called resources defined by that module into their own accounts, and we'll take a look at that in the code in a sec. And the way that you would interact with the contract is via entry functions. So entry functions are just the functions that you would create scripts to interact with from your front ends, from your scripts, wherever. And you have your view functions as well, which do not update any state and are just used for read-only access. So this is the first part of that long kind of module that I had written out before. This is kind of like how you define a smart contract on the Move side. You have your module, you have what's called a named address in this case. So the hello blockchain is actually corresponding to an address. So that is going to be the address that I'm deploying to. I would set this in like my configuration of whatever address that should be. And then message is the actual name of my module. And you can see that a little bit in action with how I import other libraries throughout the rest of the contract. So you'll see that the way that imports kind of work is that you're using the use keyword and you're importing from a specific address. So the STD or standard library, that is referring to the 0x1 address. So at 0x1, we have several different modules that I can import. One of those can be error, signer, string. In the case of string, I'm going one level deeper into the module and importing the string type. I can also import different functions for strings from that as well. But essentially, how you would import is you specify the address, you specify the module, and then you can go one level deeper, specify any types or functions that you want to import as well. Aptos framework is another address that has several more kind of like library tools for you to use. In this case, there is, we're going to be using an account, an event module that'll help us deal with our any accounts that we're using and emitting events. So I've talked about resources a couple different times. I've mentioned them. So what exactly are they? So Move applies what's called resource-oriented programming, meaning assets, which are resources, are treated as first-class citizens with very, very strict rules. And the goal here is to prevent things like duplication or destruction of on-chain assets like tokens or NFTs. So resources have different things called qualifiers. A couple of them are key, store, and drop. If it has a key qualifier, that means this resource can be published to an account's global storage. If it has store, it can be used in local variables or pass between functions. If it has drop, this allows resources to be explicitly dropped or destroyed without calling a custom function. So if a resource lacks the drop keyword, the MoveVM enforces that it can only be destroyed via a module that defines it, e.g. like a burn function. So this gives you, like, again, these different qualifiers will give you different protections on the VM level. So adding a bit more onto the contract, now we're defining two resources. Resources are defined with structs. My first struct is just this message holder resource. I gave it that key qualifier, so if you remember, this allows the resource to be published in an account's global storage. And we'll see how that kind of works out in a second. But the message holder struct has two things. The message, which is just a string, and I'm using the string typing that I imported from the standard string library, and a message on-chain event that we're going to admit, and that event is then defined in the following struct below there. So here now is kind of like the first entry function for actually setting your message, right? So if you recall back on the Solidity contract, you might do this in like your constructor, where when you deploy your smart contract, you set your message. In this case, the way that this is done is we check to see if a resource, in this case the message holder resource, actually exists on the account that is interacting with the contract at the time. So in this case, message holder, this is the actual resource that I defined. Does it actually exist on this account? If it doesn't, what we're going to do is take that resource and move it to the account that is interacting with it. An account cannot have a resource until you've actually moved the account over to it, hence the programming language move. So in this case, we're moving the message holder, which will have the message and the event associated to it. And we set that down here and emit the event up here as well. So how resources are moved in Move. In that snippet, we use the move-to function. And this places a new message holder resource into the caller's account. If that resource doesn't exist, we created it, and this ensures that there's no accidental duplication. Only one message holder resource can exist per account unless the code explicitly allows more. So if the message VM level safety, like I was mentioning, from double minting or inadvertently dropping these, different, I guess, from the Solidity side of things, you have a function to get the message. Using Foundry, you're able to do your testing via Solidity. On the MoveVM, can create accounts and call your entry functions in a controlled environment.
For being here, available. So given the fact that I don't have 20 minutes to cover everything, so I won't be able to. So if we are aiming to tokenize all the financial asset, maybe that would be overly ambitious sharding design at the cost of composability. And then but the Ethereum layer one design, single thread. Okay, many layer two many role developers, and that's why we believe Ethereum needs a layer two that can compete with like either or single thread or process couldn't handle the workload, parallel process to some result doesn't have to be unique. There could be multiple sequential orders out there. Sources share the data using optimistic and ecology is using both. It's using a combination of both. Okay, so priorities and some priorities may work against. In a way, is something that ecology chose. So there are three types of operations: migration, and there. Sorry, not this one. What's condition migration should do is to look at for any sorry, Alice wants to mint 10 tokens and Bob wants to mint 20 tokens. Currently the total supply is 100. So because these two transactions, they want to update the same variable, which is total delta, we call them delta changes. These delta changes, delta writes will be put in a buffer that the total, and you can see that 14,000 is an excellent choice for high performance.
You don't know. It's an optimistic rollup solution for scaling Ethereum. So we have stages, including memory safety, as I said. So in ROS, there's no null point from the beginning. Runs on top of Ethereum EVM, which is to be really expensive to run on chain. Yeah. So while on Ethereum compatible chain, and it is fully decentrally possible. You can do bridges at lower cost. You can do more efficient execution for gaming and AI, and you can validity counterpart to get those numbers that I'm going to walk through in the next slides. Is high gas costs from dynamic memory allocation, and our results show these are the challenges that I faced: expensive matrix generation on chain. I used event logs. Even did the heavy storage costs that Solidity had. And yeah, we were able, and storage costs remain low, even for large matrices, unlike as the size of matrices grow, and like cheaper. And again, as I said, this is the